Corporate Finance Excel practice problem. Present value of an annuity where the payments are happening at the beginning of the periods rather than at the end of the periods. Get ready, it's time to take your chance with Corporate Finance. Here we are in Excel. If you have access to the worksheet and would like to follow along, we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We're going to have the information up top. We'll do that in a couple different ways, or calculate it a couple different ways in the blue areas to the right, one with a mathematical formula. We'll take a look at a running balance type of calculation, then the formula for Excel, and finally with the table time using the annuity types of tables. The new thing that we're going to be taking a look at here from the annuity calculations we have seen in the past are that we're going to have the payments that are starting at the beginning of the time period as opposed to the end of the time period. So you need to be careful when you have a series of payments as to whether the first payment, for example, happens now, today, in which case for present value, we wouldn't be present valuing it because it's happening today. Whereas, or if the first payments basically happen at the end of the period, in which case we would be present valuing starting on that first payment. So let's take a look how that will work out. Note that the formulas that we normally will think about with an annuity represent annuities that are going to happen at the end of the period, meaning we're not starting the first payment today, but typically thinking about the annuity at the end of the time period. So here's going to be our information up top. We're going to say that we receive $4,500 per period for 12 years. We're going to use the percent at the 12%. Now we're just going to use the same formula down here, which is going to be the annuity formula, but recognize that this annuity formula is an annuity assuming the end of the time period. So what I want to do is say, okay, look, that first payment is going to happen at the beginning, meaning it's going to be in the present. And then we're basically going to have 9 periods after that, which are basically an annuity. So we can do this. One way we could do this is do an annuity for 9 periods, a normal type of annuity type of calculation, and then tack on the first payment, which is today, which we don't have to do a present value for. So let's take a look at what that would look like first with the annuity formula, which we're going to break out over here into this P times this whole thing in the outer column, the numerator then pulled into the inner columns, and so on. So we'll pull in then the 4,500, and then I'm gonna go into the 1. I'm going to put a 1 here, and then I'm going to go inside to the 1 plus R to the negative n. That's going to be in here. So we're going to say this is going to be 1 plus R, which is 12%. Percentify that, go into the Home tab, Numbers, Percentify, Home tab, Font, and Underline, and then we'll sum this up equals the SUM of these two items. We'll percentify that, Home tab, Number, Percentify. So there we have that. Then we're going to take that to the power of n, the number of periods. And this one is kind of the tricky one here because we have 10 periods that we're talking about, but we're going to start at the present rather than 1 period out. So I'm going to make an annuity as opposed to 10 periods, 9 periods, and then I'm going to tack on the first payment, which is basically at period 0, so that we could just use the normal annuity formula, which in essence assumes the payment happening like at the end of the time period. So what we'll do here is I'm going to say this is going to be negative because it has to be negative this plus 1, or in other words, negative 9 periods. And then we'll take this out. I'm going to say this is the 112 caret shift 6 caret to the 9, adding some decimals there by going Home tab, Numbers, decimalizing it, and then underlining it, Home tab, Font, and Underline. Then let's go ahead and do our subtraction problem. This is going to be 1 minus that number. So now we've got the whole numerator here. Let's decimalize that, Home tab, Number, decimalize. So there we have that. And then that's the whole numerator. We'll bring in the denominator now. That's going to be the 12%. 12% on the denominator. Let's percentify that one. Home tab, Number, Percentify. And then Home tab, Font, Underline. We'll bring this into the outer column now. This is going to be then the numerator divided by the denominator. And then we'll add some decimals here. Home tab, Numbers, decimalize. And then we'll underline in it, Home tab, Font, and Underline. And so there we have that. Now we can multiply this out. This is going to be the 4,500 times that number we just got there. And there we have it. But for some reason, I made this a negative and it shouldn't be. I'm going to make that a positive. Sorry about that. And so there we have that. I'm going to add a couple decimals down here. Home tab numbers, couple decimals. And then we're going to add to it. That would be for 9 periods. And so we kind of did a normal annuity calculation. And then I'm going to tack on basic period 1, which doesn't need to be present valued. It's because it's happening in the current time period. So I'm just going to tack on then or add to the 4,500. Another 4,500. And we'll just add those up. This equals this plus that. This plus that, and then underline, home tab font, underline, add a couple decimals, home tab numbers, add a few decimals. So there we have it. So we have to be careful about that beginning payment. So is the annuity happening basically starting now, beginning of period annuity, or are we talking the annuity is happening at the end of the period, the first payment happening at the end of the period, so that we have to present value the end of the period. Let's look at that in another way. Let's think about, well, what if we did this running balance type of calculation? What would that look like? This is a little tricky because we need to think about where our starting point is going to be. We're going to start at basically time 0. The first payment's going to happen at time 0. We're going to convert this annuity type of calculation into a present value, a series of present value type of calculations, because the annuity is happening at the beginning of the time period, like time 0. Then I'm going to put 0 and start it at 0, and then 1, and then we'll bring this on down to our number of periods, which is going to be 9 periods. 9 periods. I'm just going to format our cells here so this is all formatted properly. Let's highlight these and then center them. Home tab, alignment, and center. And then our payment, the first payment happening basically today, present value payment, is going to be that 4,500. So we'll start there. No present value formula is needed because that's starting at the first starting point. And then we're just going to present value the rest of them just as a normal kind of annuity type of process, going 1, 2, 3, down, on, down. Notice the annuity stops at 9 down here, even though there's 10 periods, because period 1 is in essence 0. And the actual annuity, which basically is present valuing as of the end of the time periods, starts at the second payment, because that's going to be a year from the current date, 1 period out, or the end of the period. So the payment is going to be then the same, 4,500, because it is an annuity, but now instead of just having that same amount, we're going to present value. We'll use our present value calculation. It's going to be equal to the present value of, we'll pick up the rate, which is going to be the 12%, which I'm going to pick up right there, and then comma. Then we need the number of periods, which is 1, even though it's the second payment, because this is the first payment of basically the annuity that we're having here. And then comma, comma, we've got the future value, which is that 4,500. I'm going to put a negative in front of the P here to flip the sign to make it a positive amount. So now this one, of course, is less than the first one because we're talking about 1 year out this time, as opposed to the first one, which is in the current day. So this is going to be equal to the 4,500 plus the 4,018. There's the 8518 about. Then let's do this again. This is going to be another 4,500. Let's do the present value again. This is going to be equal to the PV. And we will then take the rate, which I'm going to say is the 12%, comma, number of periods, now 3. Oh, I'm sorry, now 2, even though it's the third payment because of the way the annuity is structured, comma, comma. And then the future value is that 4,500, and I'm going to put a negative before the P. And then we have what we had last time plus this new value, the 3,587. Let's do it one more time, and then we'll do the autofill of it. So the 4,500, the present value this time is going to be equal to the PV, present value of, picking up the rate at the 12%, comma. Number of periods is going to be then 3 periods out, comma, comma, and then the future value is going to be that 4,500. Put a negative sign before the P to flip the sign. There we have it. Then we're going to say this equals where we had last time, where we started last time, or ended last time, where we start this time, plus the 3,203, which we present valued. Let's go ahead and copy it down. I'm going to do it one time and see if there's any problems, which there will be, then fix those problems. So I'm going to go ahead and autofill this down, select and autofill. And this one looks like there's a problem, doesn't look quite right. And that's because it's moving the percent down here. It's moving the percent down, and I want it to keep at that 12%. So I'm going to say, all right, that's going to be in cell E6. So I'm going to delete this row, double click on this item, and then E6 right there, that 12%, needs to be absolutized with an absolute reference. I'm going to do that by selecting F4, putting a $ before the E and the 6. You only need a mixed reference, but absolute reference works. That will tell the system or Excel, don't move that cell down when we copy it down like you normally do. So then we're going to then select these again. I'm going to go all the way down, living dangerously. We're not even going to check it. We're just going to go all the way down. And then there it is. And there's the 28477. I'm going to select this column. Home tab. Let's go to the numbers group, add a couple decimals so that we're at the 28477, 12. Okay, let's do this with an annuity type of calculation. So now we'll do an annuity type of calculation for it. Remember, when we think of an annuity now, I'm going to do the formula. I have to say, okay, this is going to be an annuity that starts today. So this number of payments that we have, once again, even though there's 10 of them, the first one starts today, and then we have a normal annuity of 9 periods. So we have a normal annuity that we'll have, but for 9 periods, and then we'll tack on period 0, which will be that 4,500. Let's see what that looks like in a formula format. This is going to be equal to present value of the rate, which is going to be this 12%, comma, and then we're going to have the number of periods, which is going to be 9. I'll pick it up down here, 9, even though there's 10 periods. Let's do it this way just so we can see it. There's 10 periods, and then I'm going to subtract 1 because the payments are happening at the beginning, and then we'll tack that payment back on at its full value of the 4,500 due to it being at the beginning of the period and not needing to be present valued. So we're going to then bring this back on over. So now we got this minus that, which is 9 periods, and then comma, and we have the payment, which is going to be the 4,500. So I'll just pick that up here. I'm going to close that up. I'll put a negative before the P to flip the sign. And there we have it. Now that is the annuity for the 9 period section. Now, and that ties out to this item. Now I'm just going to tack on period 0, which doesn't need to be present valued. And I'll just do that within the formula. I'm going to say, go back in here, go to the end of it, just say plus the first period, which doesn't need present value timing, isn't really part of the annuity. We're just tacking on period 0. So it's an annuity of 9 plus period 0, which is at 4,500. And there we have it. Let's do it again with the tables, ending it off with table time. And so we're going to start off same kind of concept with the tables. So I have my information over here. I'm going to say, yeah, they gave me 10 periods, but the first payment starts today. So really the annuity, when I'm thinking about like a normal annuity table, I have to go with 9 periods and then tack on period 0. That means when I look at the table, I'm looking for 12% and 9 instead of 12% and 10. So I'm going to go down here and say, all right, 12%, and 9 is right there. That's going to be 5.3282, 5.3282, 5.3282, 5.3282, 5.3282. We'll then add some decimals, home tab, numbers, decimalize. Then home tab, font, underline. We'll put the payment up top, which is going to be that 4,500. Multiply this out, the 4,500 times that amount we got from the table. And then we got to tack on that first payment, the payment 0. So I'll call this the first payment, which is going to be at the 4,500, it being at time 0. Therefore, no present value stuff needs to be done to it. I'm going to go to the home tab, font group, and underline, and just add that up. This equals the 23,977 plus this amount here. We get the 28,477. Let's add a couple decimals. Home tab, numbers, decimalize. So there's the 28,472, 28,476.90. Slightly different than the 28,477.12. It's kind of a larger difference than I would have expected. Let's just see what that difference is exactly. And so it's not, it's pretty, 22 cents. But why is that difference there? It's because they rounded the table to the 4 digits, 5.3282. Whereas over here, if we see it, and if I was to calculate this, it would be 5.3282499792. And that could result in rounding differences typically not being something to worry about for decision-making purposes, but can be something that test questions can utilize to force you to use one method or another. So be aware of that.